Okay, today we will discuss about a transformation named Z transformations. We already have known about Fourier transformation, Laplace transformation, and this is also another transformation. It's sequence related transformation, Z transformation. First of all, we'll define the Z transformation definition, application of Z transformation in engineering and in our real life. Then examples of we show different kinds of example of Z transformations and geometrical interpretations of Z transformation. Then problem solving from lecture sheets. Now Z transformation Z transform is used in many applications of mathematics and signal processing, especially. The list of applications of Z transforms are uses to analysis of digital filters, used to simulate the continuous system, analyze the linear discrete system, used to finding frequency responses, analysis of discrete signals, helps in system design and analysis, and also checks that system's stability. That means test the stability for automatic controls in telecommunication. Automatic it is also this transform also used to for automatic controls in telecommunication, especially electronic and telecommunication engineering. You are ETA students, you must know about it. For automatic controls in telecommunications, enhance the electrical and mechanical energy to provide dynamic nature of the system. To design and dynamic nature of the system, we have to apply jet transformation. uh, Now if we see the main application of jet transform, then we find that it is always tool that analyze the whole discrete time signals and systems and their related issues. If we talk the application areas of this transform, wherever it is used, there digital signal processing, population science, controlling theory. You must know controlling theory about using dynamical system, is maybe linear system or non-linear systems. This is the very important topics in engineering. Look like Tripoli, CSC, CCE, etc. Now, as an introduction, jet transform plays an important role in discrete analysis. Discrete analysis, not it is not for continuous analysis, but it will be discrete. The time value will be discrete. Its role in discrete analysis is the same as that of Laplace and Fourier transform in continuous system, but Laplace and Fourier can be applied in continuous system. So its role in discrete analysis is the same. There is actually no discriminant between Laplace between jet transform and Laplace Fourier, but Laplace and Fourier transform can apply in continuous system, but it has similar role in discrete analysis. Who has similar? Actually jet transformation has similar role in discrete analysis. That means discrete system. Another one is communication is one of the field whose development is based on discrete analysis. Actually you must know, you're the students, engineering students, and as engineering students you must know communication. In communication we have to in the field of in the communication field we have to the development, maximum development only for what? Discrete analysis. Maximum theory we apply to develop the communication the different application is based on discrete analysis. Difference equations are also based on discrete system, and their solutions and analysis are carried by jet transformation. Actually this is the our introduction. Now what is Z transformation? The Z transform is the discrete time cosine of the continuous Laplace transform, while the Laplace transform is used to simplify the analysis of continuous differential equation. The Z transform facilitates the analysis to discrete difference equation. Remember it. In Laplace, always used where continuous differential equation, but Z transform facilitates us to analyze and help us to analyze the discrete difference equation. Z transform of discrete sequence and expressed as Z is defined as z as this is a sequence series n equals to minus infinity to plus infinity h n z to the power minus n, where the variable z is must be complex. Z is the complex number. The above equation allowed us to take the Laplace transform of a continuous signals. The Z transform is performed on a discrete system Hn sequence, converting the sequence into continuous function Hz of the continuous complex variable. That means this sequence actually used to convert continuous signals to discrete and discrete to complex continuous. And here variable is also used. Now this is the geometrical interpretation of Z transformation. There are two plane, one is S plane and the other is Z plane, and this is the real part of Z plane, and this is the imaginary part, y axis. This is also real part and imaginary part of our S plane. In mathematics for learning, you must know about this transformation. In topic section, if you click topic section, you will get the transformation, different kinds of transformation. From there, you will get there are available information about transformation, geometric interpretation. You can visit the group. So you can use this geometric interpretation for an example. Actually, omega is the, you must know, omega is the angular velocity. Angular velocity will be start from here. This will be exist uh, from zero. Angular velocity first of all zero, then here unstable region, not stable, but after turning, then this will be negative in third quadrant. Start with negative omega means you must know angular velocity. Total time, total capital T will be the time period. Now for S plane, this is S plane, stable region will be this and stable will be this, but this is with the unstable, and the whole shaded of this circle will be the, and in first quadrant will be exist only stable and other is non-stable. This is the geometrical interpretation for you. এখান থেকে আমরা একটু স্টার্ট করি। First of all, sequence f of k is an ordered list of real or complex numbers. Ordered list, this is a list of order. Representation of a sequence. First method, there are two methods actually to represent a sequence. The elementary ways to list all the members of the sequence such as f of k 15 10 7 4 1 minus 1 0 3 6. This is the random numbers. The symbol, this is used to denote the term in zero position. Actually this is in zero position, that is k equals to 0. মানে first sequence, first will be started with k equal to 0. This sequence start from what? K equals to 0, and k is the index position of a term in the sequence. K is the index position of a term in the sequence zk equals to 15 10 7 4 1 minus 1 0 3 6. That means this is 15 10 7 4 before 1 minus 1 0 3 6. There are these two sequence, fk and z of k have the same terms, but these sequence are not identically the same as the zeroth term of those sequence are different. Zeroth term are different. Here the zeroth term 15 and here the zeroth term what? 4. This is why this is not identical. In this case, this symbol is not given in the left hand term, is considered as the term corresponding k equals to 0. In the sequence 8 6 3 minus 1 0 1 4 5, the zeroth term is 8. First term what? Zeroth term. This is will be 8. Left hand and term. It considered from the left. Now second method we can consider, for example, f of k equals to what? 1 by 3 to the power k. For every k we get this sequence. K equals to 1, k equals to 0, then will be what? 1. K equals to 0 for this, right? This is for what? K equals to 0, and this for k equal to 1, k equal to 2, k equal to 3, and k equals to minus 1, k equals to minus 2, k equals to minus 3. Then we get this whole sequence. So this one will be for k equals to 0. Now f of k equals to 1 by 3 to the power k minus 4, k lies between what? Minus 4 to 3. Minus 4 to 3. Then we can write this sequence. Just we got an idea about sequence. Now jet transformation. Actually concentrate please, everybody. This is the definition of jet transformation. Now we can define the jet transformation as the jet transform of a sequence f of k is denoted by, this is also a sequence and can be denoted by jet. This is the third bracket f of k, second bracket and third bracket. It is defined as this z transformation of f of k. This is called z transformation of the sequence f of k. Remember, sequence always represented with second bracket. Sequence always represented with second bracket. This equals to f of z. This equals to what? Only z. This sequence are represented by z equals to k equals to minus infinity to plus infinity f of k z to the power minus k, z to the power minus k. This also can be written as k equals to minus infinity to plus infinity f of k divided by z to the power k, where z is the complex number and z is the operator of z transform. Capital Z will be the operator. Capital Z will be the Z transform. A small z will be what? Complex number. Remember it. And capital F of Z is the Z transform of f of k. Sequence. This is the sequence. Sequence always represented with second bracket. Remember it. Now follow this example. Example 1. Try example 1. If f of k is this sequence 15 10 7 4 1 minus 1 0 3 6, then the z transform of sequence f of k, f of z equals to, this is the symbol of z transform, z transformation. This equals to minus this is 15 z cube, this 10 z square, 7 z.
So z cube আসছে স্যার, cube আসছে কি?
Actually I will tell you last at last. 15 z cube, 10 z square, 7 z 4 will be z to the power 0, and this will be z to the power minus 1, z to the power minus 2, z to the power minus 3, z to the power minus 4, z to the power minus 5. This will be the whole sequence, z to the power minus k, right?
আচ্ছা আচ্ছা জি স্যার বুঝতে পারছি।
First will be z to the power 3, z to the power 2, z to the power 1, z to the power 0. 4 into z to the power 0, but 1 into z to the power what? Z to the minus 1, minus 2, minus 3, minus 4, minus 6. In this way we have to write this sequence for z transformation. Similarly, for example 2, if zk equals to this, then we will start from this 0, 1 2 3 4 5 6 7. This way this will be z to the power 7, 15 into z to the power 7, 10 into z to the power 6, 7 into z to the power 5, 4 into z to the power 4, 1 into z to the power 3, but minus 1 into z to the power 2, 0 into z to the power 1, 3 into z to the power 0, right? 3 into z to the power 0 and 6 into z to the power minus 1. This is why 6 by z. Very easy. Similarly, example 3, z transform of sequence this is this. Okay, starting from 8, starting from 8, z to the
8.
power 0, z to the power 0 into 8, z to the power minus 1 into 6, 3 into z to the minus 2, minus 1 into z to the minus 3 in this way. Very easy. Now example 5 also can be written. 5, 6, 7, every example you will understand. Okay, now we will study about the properties of jet transformation. First property is linearity property. Linearity property. Suppose if f of k and zk are the such that they can be added, a and b are constants like this. Jet transformation of a into sequence f of k plus b into sequence z of k can, if we get this result like this, a into jet transformation of individual transformation of f of k plus b into individual jet transformation of g sequence zk, right? And if this property is satisfied, this is called linearity property of jet transformation. Now proof how we'll prove it. Jet first of all, jet transformation of this whole sequence, this is whole combinedly one sequence, remember it, combinedly one sequence. Now using the definition of jet transformation, previous definition, k equals to minus infinity to plus infinity, just f of z, right? This one, f of k into z to the power minus k, right? Now k equals to minus infinity to plus infinity, z to the minus k multiplying in both part, a into f of k, z to the minus k, b into gk, z to the minus k. It can be written as separately, a into k equals to minus infinity to plus infinity, f of k, z to the power minus k plus b into this. This is also a jet transformation of individual jet transformation of f of k. That means a into z transformation of f of k plus b into z transformation of zk sequence. So we proved that this property satisfied, and this is also linearity property satisfied. Clear? Now example 8, find the jet transform of f of k sequence given. F of k is the sequence where 5 to the power k will be negative, that means less than 0, and 3 to the power k where k is non-negative, that means positive and 0. Non-negative means what? Positive and 0. So 5 to the power k will be k less than 0, and 3 to the power k will be k greater or equal to 0. 5 and 3, remember it. So we can draw a circle for 5 radius and another circle in 3 radius. We can draw. This is the complex plane. This will be in the complex plane. Now jet transform of f of k, jet transform of the sequence f of k, given function f of k equals to this, the use by using definition, k equals to minus infinity to minus 1, minus infinity to minus 1, 5 to the power k, z to the power minus k, minus infinity to minus 1 will be k less than 0, this is why 5k, understand? And 0 to infinity what? 0 to infinity 3 to the power k, 3 to the power k, z to the power minus k, always multiplied by the definition of jet transformation. Now dividing it into two parts, we get this one, just putting minus infinity to minus 1. This sequence can be written as 5 to the power first of all minus 1 minus 5 to the power minus 1, just putting k equals to minus 1, k equals to what? Minus 2, k equals to minus 3, in this way minus infinity. Okay, minus infinity will never be finished in left, never be finished in left. First term will be what? Minus 1. Z equals to what will be? Minus 1. We get this. Z equals to minus 2, we get this. Minus 2. 5 to the power minus 2. Z to the power minus 2 into minus. That means Z square. Then for Z equals to minus 3, 5 to the power minus 3, and Z equal to Z cube will be minus minus plus. This is why. And in left, if we go up to minus infinity, then it will be never finished. Earth will be finished, universe will be finished, but counting will never be finished. Now for second part, plus second part, just putting k equals to 0. K equals to 0 what? At 3 to the power 0, 1. Z to the power 0 also 1. This whole 1 first term. Then uh, after 0, k equals to 1 will be give this. K equals to for this. K equals to 3 for this. Plus dot dot. This is the geometric progression, right? Geometric progression you must know. Infinite series. Infinite series. The sum of geometric series in geometric infinite series s equals to what? First term divided by 1 minus common ratio. A divided by 1 minus r. Common ratio. R is the common ratio. A is the first term. And so sum can be written as like this. First term. This is the first term, right? First term. First term divided by 1 minus common ratio what? Common ratio means second term divided by first term, or third term divided by second term, common ratio. Then for this series we can write first term what? 1 divided by 1 minus a means what? Second term divided by first term, or third term divided by first term. This is the properties of geometric series. Now putting the common ratio r, 3 divided by z to the power minus 1, we get this. Now this can be written as taking LCM, least common multiple, we get in down 5 minus z into z minus 3, then in up multiplying with numerator after dividing this with this 5 minus z divide this one, we get z minus 3. Z minus 3 into z what? Z square minus 3z plus z into z minus 5 minus z, 5z minus z square. After subtracting we get this. Here z by 5, z by 5 is less than 0, right? Z by 5 less than 0, z by 5 less than 0, and z by 3 by z, sorry, 3 by z what?
Less than 1.
Less than 1,
Yes, sir.
because whole 1 is negative. This is why less than. This is also less than. Two series are convergent in annulus. Here just taking cross multiplication, 3 less than absolute value z, and z absolute value z will be less than 5. That means what? This is the circle in complex form. This is the absolute value z means what? Circle whose radius is square root 3 and radius is 3 and center will be 0 0, and its radius also 5 whose radius is 5 and center will be 0. Absolute value z means what in complex form? This is the circle.
Okay, sir.
Example 9, find the z transform of this sequence, second bracket, a to the power absolute value of k, right? A to the power absolute value of k. Find the z transform of this. Now z transform of this of the sequence a to the power k can be written as k equals to minus infinity to plus infinity a to the power k. This is the just sequence function a to the power k, then z to the power minus k by the definition. By the definition we can write this. We can divide into two parts. One is k equals to minus infinity to minus 1, other one is 0 to infinity, right? Writing this like as before, equal to, just putting first term will be what? Minus 1. Putting k equals to minus 1 in this will be as it. Then minus 2 will be this, minus 3 will be this, minus minus plus. This is why only all are positive. In this way we can write in left up to minus infinity. Okay, up to minus infinity. This term will not be finished, putting all the values up to minus infinity to minus 1. First term will be minus 1 this, minus 2 this, minus 3 this, and up to minus infinity. Now for the second one, if k equals to 0 to infinity, then after putting k equals to 0 here, then we get only 1. Something to the power 0 equals to 1 if something is greater than 1. But this will give for 0, k equals to 0, 1. K equals to 1 will be what? As at inverse a into z to the power minus 1. Now k equals to 2 will give this a square z to the power minus 2. K equals to 3 this. This is also geometric progression. Look like before. These are two geometric progression. So the sum will be formula, a divided by 1 minus r, where a is the first term and r is the common ratio. This equals to first series can be written as like this: first term divided by 1 minus common ratio plus similar second series can be written as 1 divided by 1 is the first term a, then this is the formula 1 minus this is the common ratio r for the second series. Here az less than 1 and az inverse also less than 1, less than 1, remember it. This is the less absolute value. That means az lies between minus 1 and 1, and az inverse also lies between minus 1 and 1. Absolute value means this. So this equals to can be written as az divided by 1 minus z plus z divided by z minus a. Z how? This is the a by z taking LCM. Now taking LCM we get this one. This is the z transform of the sequence a to the power k absolute value of k. Similar, you can find the z transform of 1 by 2 whole to the power k absolute value of k. Z transform of this equals to can be written as summation. This summation will be what? Minus infinity to minus 1. And taking minus infinity to minus 1 first term, then k equals to 0 to infinity second part. Then it's also what? To series, geometric series progression. Now the infinite series will be in geometric progression. So sum will be this, and similar process. First term divided by for first series, first term divided by 1 minus common ratio plus first term divided by for the second series. First term will be 1 minus common ratio for the second series. Common ratio. This is the geometric progression. Common ratio means first term divided second term divided by first term. Then taking common, we get this one. Taking least common multiple LCM, we get this one. This is the required result. Similar process we can find out this also. Next one, 12 the find the z transform of discrete unit step. Discrete means what? The domain value will be separated. First k value will be negative, second k will be non-negative. This is why the sequence uk equals to 0 will be when negative k. For negative k, value will be range value will be 0, and uk value 1 if k is non-negative. Then this the z transform of this sequence uk can be written as by the definition like this, and this is a 0 to infinity. 0 to infinity, why 0 to infinity? Because non-negative, where non-negative value this only 1, 0 we cannot calculate 0 1. This 0 cannot be accepted because k less than 0. So only can be defined 0 to infinity. This sequence for what? Only 1. This is why 0 to infinity used here. So this can be written if k equals to 0 first term, k equals to 1 second term, 2 3. This is also a symmetric series, infinite series, symmetric infinite series. Now using this same formula we get this one, and this is the required transformation. Similarly, Laplace transformation of sine alpha k. This is the sequence sine alpha k given for k equals to k non-zero. Non-zero means what? 0 to infinity. 0 to infinity. Sine alpha k into z to the power minus k. Z to the power minus k comes from where? Definition. And this is the given sequence function of sequence. Now sine alpha can be written as in exponential form. E to the power I alpha k. Alpha k is the angle. So e to the power I alpha k, it minus e to the power minus I alpha k divided by twice I. This is the exponential form of sine. So we can divide it into two parts, taking common in 1 by twice I before the summation. Then summation k equals to 0 to infinity will be first exponentiation form, this multiply this, then minus 1 by twice I, second one will be e to the power minus I alpha into z to the power minus k. Just taking these two differently, 1 by twice I, k equals to 0 to infinity. This is the first one taking k in common as a power, right? Taking raising each every term to power k. K is the common power for them. This is why we can write like this. And here also we can take k as the common power of this whole term, e to the power minus I alpha z to the power minus I n minus 1 to the power k. Then for putting k equals to 0 to infinity, k equals to 0 to infinity, first term will be 1, second term will be k equals to 1, this only. Third term will be this whole square. For k equals to 2, k equals to 3, this is up to infinity. This will be never finished term, so infinite series. Another part minus 1 by 2 I similar putting k equals to 0 to infinity. 0 to infinity, if k equals to 0, this only 1, something to the power 0, only 1, plus this will be first term, plus this will be the for k equals to 2, then dot dot up to infinity. This is also both series, there are two series, and these two series are infinite series of geometric progression. So we can use the formula, above formula, a divided by 1 minus r, a divided by 1 minus r formula, same formula. R means what? Common ratio. Second term divided by first term. First term is 1, a 1. This is the formula 1 minus this is the common ratio. Common ratio means second term divided by first term or third term divided by second term, same. Then for this second series, minus 1 by 2 I 1 divided by 1, first term 1, this is the formula 1 minus this is the common ratio for the second series, common ratio. Then we get z inverse z to the power minus 1 can be written as in the numerator, z divided by this one. Now taking LCM, we get this one. This is the whole. It can be written as sin alpha. This is also cos alpha. Okay. This is the result. Exponential form in complex number, you will get this formula. You will get this formula, sin alpha k equals to this. In complex number, it has formula. Next, number 14, similar. Find the z transform of c to the power k cos hyperbolic alpha k. C to the power k cos hyperbolic alpha k. Now z transform of this whole function of sequence, c to the power k cos hyperbolic alpha k. This is the whole f of k by the definition. So k equals to 0 to infinity. Condition given 0 to infinity. K is non-zero. That means what? K will be 0 to infinity. So this is by f of k by the definition, and z to the power minus k also from definition. So using definition, we can write the one z transform as now c to the power k divided by 2. These two from where are coming? Cos hyperbolic alpha k, converting cos hyperbolic to exponential form. In exponential form, cos can be written as e to the power alpha k plus e to the power minus alpha k divided by 2. Okay. You must know it. Cos hyperbolic alpha k equals to e to the power alpha k plus e to the power minus alpha k divided by 2. Now separating ck to the power c to the power k divided by 2. Then we get this. Now z to the power minus k multiplying in both terms. So half into c multiplying with e to the power alpha k and z to the power minus k, we get altogether c into e to the power alpha z to the power minus. Then taking power as common from all terms of first term, plus second half k equals to 0 to infinity. Then for second term, we can write c to the power k e to the power minus a k z to the power minus k like this. So after putting 0 to infinity values of k, we get the series first series this, and this will be the second one. You must know this z must be greater than what? C into e to the power alpha. C into e to the power alpha. Why? Z to the power absolute value. C into e to the power alpha. This can be written as c to the power alpha divided by z, right? C e to the power alpha divided by z can be written. Okay. So this z must be greater than what? C into e to the power alpha. For the second one, this divided by z. So this z always greater than c into e to the power minus alpha. For the second, this is for second series, and this for the first series. Condition must be satisfied for this series. Now just solving this infinite series of geometric progression. This is why using the same formula as before, this will be first term a equals to this, and 1 for formula of sum of formula of geometric progression, 1 minus, this is the common ratio r, second term by first term, or third term by second term, we get the same one. So for the second series, this is also sum of the infinite series, a equals to first term a divided by 1 formula 1 minus, this is the common ratio for the second series. Now just taking z to the power minus 1, taking LCM, least common multiple, we get this result. Now you have to convert this into hyperbolic function. This will be the cos plus, will be the cos hyperbolic form alpha, cos hyperbolic alpha, multiplying by z square, we get this one. Multiplying by z square on both numerator and denominator, we get this result. Now corollary, if c equals to 1, then we get this one result. In any test, this question may come, you will say, question may come as find out the z transform of this one, cos hyperbolic alpha k, cos hyperbolic only alpha k. For c equals to 1 will be, this will be the result. Similar process, example 15 also, find the z transform of cos hyperbolic this whole angle k pi divided by 2 plus alpha. This is the hyperbolic function. This function defined on hyperbola. This is why hyperbolic function. Now the z transformation of this function can be written as by the definition, sequence z to the minus k. Just cos hyperbolic formula, what? E to the power angle, e to the power angle plus e to the power minus angle. Remember it, divided by 2. This angle only, theta, look like theta angle, divided by 2. Converting this hyperbolic function cos to exponential form, z to the minus n. Similarly, we get 2 series and also infinite series will be. This will be the also infinite series. Now we get e to the power alpha as common. E to the power alpha will be common. Separating e to the power alpha and e to the power minus alpha also from the second one. Separating, and half also separated. Half e to the power alpha by 2, e to the power minus alpha by 2. This is the whole, taking whole power k as a common power. Right? Look like before example. So e to the power alpha by 2, this will be the first series after putting k equals to 0 in replace of k. First one, k equals to 0, k equals to 1 for this, k equals to 2 for this, plus dot dot up to infinite series. This is why it will never be finished. Plus half e to the power minus alpha, similar process, after putting k equals to 0 in first term, k equals to 0, something to the power 0 will be 1, plus this whole to the power k equals to 1 for this, k equals to 2 for this, and plus dot dot up to infinite. So symmetric series sum, you must know about this formula. First term divided by 1 minus common ratio. This is the r is the common ratio. Now applying this formula for the first series this, and for the second series this one. Now taking L together by taking LCM, least common multiple, we get this one. Now convert, we must convert the exponential form to hyperbolic function, because our function was given in hyperbolic function. This is why after we have to arrange this one. Arrange e to the power a, e to the power alpha plus e to the power minus alpha by 2. What will be cos hyperbolic alpha? Remember it. E to the power alpha minus pi by 2, e to the power minus alpha minus pi by 2, bracket 1. This is why this will be cos hyperbolic alpha minus pi by 2. Now z to the power minus 1. This is also can be written as taking common 2 into cos hyperbolic pi by 2. Z to the power minus 1, z to the power minus 2. Now we have taken multiplying z square in both numerator and denominator. Okay, multiplying this one with z square, we get this one. Multiplying z square with this, we get this one. That means inverse z. We inverse z cancel. Negative to avoid negative power of z, we have to multiply z square on both numerator and denominator. This is the actually result of this is the complex form relation between circular function and exponential function. Circular function and exponential function. Cos z can be written as e to the power I z plus e to the power minus I z divided by 2, right? And sin z equals to what will be e to the power I z minus e to the power minus I z divided by twice I. This formula you have to use. And also in hyperbolic function also. This is the main chart formula. Circular function of a complex number. Cos theta can be written as e to the power I theta plus e to the power minus I theta just divided by 2. That means e to the power I into angle for circular function. You have to remember I is used, but in hyperbolic I absent. Sin hyperbola equals to what? E to the power x minus e to the power minus x divided by 2. This is the cos hyperbolic form. Hyperbolic x equals to e to the power x plus e to the power minus x divided by 2. Observe that cos hyperbolic in plus, but cos in circular function this also plus, but in circular function I is present, and in hyperbolic I is absent. Remember it. Similar formula, but I is present here and I is absent here. Similar for sine also. In sine formula just minus and twice I, but here I is absent. I will be absent. Sine hyperbolic x will be e to the power x minus e to the power minus x divided by 2. And sine hyperbolic theta also e to the power theta minus e to the power minus theta divided by 2. Just I will be absent only. And this chart is used for this z transformation. Remember this chart. Now similarly for example 16, find the z transformation of sine this. This is the function sine thrice k plus 5, and the z transformation of this one from by the definition we can write this k equals to 0 to infinity. Now k equals to 0 to up to infinity, this sine angle sine theta formula what in exponential form e to the power I theta minus e to the power minus I theta divided by twice I, right? Similar formula. Okay, clear?
Yes, sir.
This one sin theta equals to e to the power I theta minus e to the power minus I theta divided by twice I. This formula used. That means circular function and complex and exponential function relation between this one. This formula is used here only. So this sin theta angle theta means 3k plus 5, just 3k plus 5 z to the power minus a. Similarly, z to the power minus k multiplying with first and second, we get two sequence individually. This first series will be k equals to 0 to infinity e to the power I into this z to the power minus k, and this will be minus 1 by twice I k equals to 0 to infinity e to the power minus I 3k plus 5 z to the power minus k. Now 1 by twice I just e to the power 5, e to the power 5 separating, e to the power 5i separating exponential function e to the power 5i, and also here e to the power minus 5i, just I multiplying, then you get, we can separate this e to the power I3 minus I3k e to the power minus 5k. It also can be written as e to the power I3k into e to the power 5k, right? Just separating these two, we get this one e to the power I5, this constant k equals to 0 to infinity. This is the making it power up to power k as a common power. Now for this second series also e to the power minus 3i z to the power minus 1 to the power k, common power k. Now after putting the values k equals to 0 to infinity, if you put k equals to 0, then first term will be what? 1, something to the power 0 1. Then k equals to, for k equals to 1 second term, for k equals to 2 third term, dot dot up to infinity. Now minus 1 by twice I e to the power minus 5i, this is also constant one. Now this series can be written as like, after putting k equals to 0, first term will be 1, second term will be k, for k equals to 2, third term will be for k equals to 2. This will be k equals to 1. This will be k equals to 2 plus up to infinity. This is also geometric progression infinite series and can be written as the sum s equals to a divided by 1 minus r. A equals the first term, 1 minus r is the common ratio. R is the common ratio. So we can write this one. We can write first term divided by 1 minus common ratio for the first series. Similarly, this also can be written as this series can be written as using this series first term divided by 1 minus common ratio. Now taking LCM, we get this result. Just arranging e to the power I5 minus e to the power minus I5. This will be what? Sine 5. Sine 5. Remember it. And it is also another formula. Sine 2 formula. Sine 2 can be written as e to the power twice I minus e to the power minus twice I twice I. Just 2 is the angle only. Then in denominator we can write e to the power thrice I plus e to the power minus thrice I can be written as 2 cos theta because 2 is absent here in formula. So to make a formula 2 into divide by 2, this way this equals to cos 3 and 2 multiplied here. So now omitting my negative power, how? Multiplying z square on both numerator and denominator. Okay, multiplying z square here we get, and multiplying z square in down we get this last one. Very easy for you. This series also very easy for you. This 17 will be homework for you. 17 and for c is equal to 1. This 18 also same formula. This is also 19 20 20 19 20. You will do it at home. Try it at home. I hope everybody will do this. Now
স্যার এই চারটা করবো 17 18 19 20
19 a little bit different. Now try to discuss 19 one a little bit different. Now find the z transform of the sequence NCK. This is the combination formula. You must know permutation combination about you must have an idea about permutation and combination. This is the combination C, the NCK. Taking k numbers from n number of things. This is the sequence, and k lies between 0 and n. Okay, k equals to maybe 0 or k equals to n, but k must be lies between 0 and n. So z transform of this sequence NCK combination C, this equals to can be written as by the definition NCK z to the power minus k. Now after putting k equals to 0 to 1 0 to n, we get this is not infinity. Remember it, the series not infinite series. Why? Because k lies between 0 and n. In combination, this is the first condition. What will be? K lies can never be k can never exceed n. K can never exceed n. That means k cannot be greater than n. Understand? This is the first condition of combination. So k equals to 0 to n can be written as like this series. After putting k equals to 0, we get 1. Then after putting k equals to 1, nc1, nc2, nc3, in this way we get a series. This series can be written as binomial expansion 1 plus z to the power minus 1 to the power n. This is the expansion of what? Binomial theorem. In intermediate you got this theorem, a plus x whole to the power n. Similar process we can write this combination k plus n cn, and this n can never be exceed k plus n. This why this n lies between what? This n must be less than k plus n. So NCR formula can be written as n c n minus r. Do you know this formula? This is the combination formula. NCR can be written as n c n minus r. So we can write k plus n cn as like this, k plus n ck. How? Using this one. NCR can be written as n c n minus r. That means difference between k plus n and n. What? Only k. Difference. k plus n, and n will be difference only k. This is why this can be written as this using this one. So after putting 0 to infinity, this is the 0, k is the greater than 0, k greater than 0, this is why 0 to infinity. Now using this series, putting the value of 0 to infinity, value of k, uh, if k equals to 0, some nc0 what 1, remember it, nc0 1, something c0 in combination formula 1, remember it. So we get 1 plus nc1 nc2, just putting k equals to 1, this one, k equals to 2 for this, k equals to 3 for this. Now we can write this series, and nc1 means what, n plus 1 into this, nc2 means what, n into n plus 1 divided by factorial 2, right? nc3 what, n into n plus 1 n plus 2, n means what, n plus 2, right? Divided by factorial 3, z to the minus 3. And this whole series can be written as like this, like this. Just introducing my negative minus, we have to introduce another minus here to balance negative sign. Now here also, that taking minus negative minus, we can balance here minus 1 minus this one. Then this is the expansion of binomial theorem, whose 1 minus z to the power minus 1 whole to the power minus n minus n 1. The power will be what? Minus n minus 1. This is the expansion of binomial theorem of this series. So this is the actually representation of Z transformation of what? Given sequence. Understand? 21 similar process. You will try it at home. Similar formula NCR equal to NC and minus R using. The transform of this can be written as by definition like this. So k equals to 0 to infinity, n plus 1, Cn can be written as k plus n ck using this. Just taking subtraction n minus n and r. That means n minus r here. So in down, in replacing n by what? K plus n minus n. K plus n minus n money means what? Only k, single k. This is why k plus n ck equals to this. So this series can be written as k plus n ck as z whole to the power z to the minus 1 to the power k. But here z must be greater than absolute value of a. That means z will be the circle with radius this. Z lies between what? Minus a to plus a. Otherwise, this will be not convergent. Now, this series can be written as binomial theorem. Look like example, previous example. This series can be written as binomial expansion of this. Now, if n equals to 1, then we get this series, right? If n equals to 1, we get this series. If n equals to 2, then we get this result. If n equals to n minus 1, then we get this result. That means there are 3 types of result for different n. For n equals to 1, this one. For n equals to 2, this 2. For n equals to 3, this one. This is this example 22. Very, very small example and easy also. Just putting the definition and writing the series, we get the required result. This is the exponential series, exponential form of series. 1 plus x divided by factorial 1, x square by factorial 2, x cube by factorial 3, x to the power 4 by factorial 4, x to the power 5 divided by factorial 5. This is the series of what? E to the power x. X means what? As z to the power minus 1. This is the x. This is the variable. As z to the power minus 2. This will be not 2. As z to the power minus 1. This will be minus 1. This will be not 2. There is a printing mistake. As z to the power minus 1. Every term will be x. Term is x. So e to the power x formula. This will be e to the power a by z. This is the Laplace z transformation of the sequence this. Now there are in exercise there are many problem for you. You will try it at home. 1 to 8. Please note down 1 to 9. 1 to 9. You will try it at home. Uh, in test comes will from this 1 to 9 homework for you.